Lesson 4.2 is on generating equivalent expressions. One of the things we need to talk about in this lesson is the distributive property. The distributive property says if a number is right next to a set of parentheses and inside the parentheses they're either adding or subtracting, you can multiply the number by all the terms inside the parentheses. So for example, if we have 2 times the quantity 3 plus 5, we could use the distributive property and we could say that's equivalent to 2 times 3 plus 2 times 5. If we were to work that out, 2 times 3 is equal to 6, 2 times 5 is equal to 10. We need to do our multiplication before our addition, and then 6 plus 10 is equal to 16. Now, I know doing this problem you would not normally do the distributive property. Normally you would just do order of operations. So order of operations, you could say that you could work in the parentheses first, and you could say 3 plus 5 is 8, and then 2 times 8 is 16. If you'll notice what we got there, we got 16. Doing the other way with the distributive property, we got 16 as well. The reason I mention this idea of the distributive property is that sometimes we are going to have variables and we don't know what the variable is equal to, then this is the only way that we can do anything to create a different equivalent expression, which in turn is going to allow you to make it easier for you to solve equations later on as well. So a second example, we have 4 times the quantity x plus 2. Times the quantity just means we have something inside parentheses. So for the distributive property here, we would do 4 times x plus 4 times 2. And then 4 times x is 4x, 4 times 2 is 8. So we can say that 4 times the quantity x plus 2 is equivalent to 4x plus 8. So in this section, we're talking about equivalent expressions. So it might be good to know what that means. So equivalent expressions have the same value regardless of the value that is substituted for the variable in the expression. So for example, we could have 5x plus 10, 5 times the quantity x plus 2, and 10 plus 5x. Those all have the same value. And one way we could do this, we could substitute a number in place of x. I mentioned 1 here. Maybe let's adjust that and let's try 2. Okay, so it'll be equal for anything. The reason I'm changing it to a 2 is that sometimes you might put a 1 in and you might get the same thing even though they're not equivalent expressions. 2, any number besides 1 or maybe 0, those are usually good numbers to try. So if we substitute a 2 in place of this, that would be 10 plus 10, which is 20. In the second one, if we substitute a 2 in place of x, we can do order of operations in the parentheses. 2 plus 2 is 4. And then 5 times 4 is 20. And then in the last case, 5 times 2 is 10, and then 10 plus 10 is 20. So if you notice, all 3 cases we got the same thing, and you might say, well, you picked what number it is. Well, that's fine. You can pick whatever number you want. If you want to try 10, if you want to try 1,000,000, if you want to try -7.5, if they're equivalent expressions, whatever number you put in place of the variable, you'll get the same answer when you simplify that and work it out. So the next thing we're going to talk about is like terms. So for like terms, the variable part is identical or there is no variable. In other words, we just have a constant. So some examples of like terms, 3x and 2x are like terms. Notice they both have an x. 5 5y squared and negative 3y squared are like terms. Those both have a y squared. 5 and negative 4 are also like terms because those are just constants. There's no variable on either one of these. We'll also talk about a non-example, something that's not like terms. So 2x and 6x squared are not like terms. Even though they both have x's, one is just a plain x and one has an x squared. So because this is just a plain x, this one's an x squared, because of that exponent, those are not like terms. And you might wonder, why do we care about like terms? The reason we care about like terms is because like terms can be combined. So one of the things we're going to be asked to do is to try to simplify expressions. And one way of simplifying expressions is by combining like terms. So for example, if we had 3x plus 2x, since those are like terms, I can combine those together. So 3 times something plus 2 times something, that's the same as 5 times something. So 3x plus 2x is equivalent to 5x. 5 minus 4, you know, is equivalent to 1. So anytime we have like terms, those can be combined together. So one question we might be given in this section is they might give us several expressions and ask which of them are equivalent and explain. So one thing I like to do is just try to simplify. If they're equivalent, they should simplify to the same thing. So if you look at this first expression, we have 10y plus 5. 10y and 5 are not like terms. One has a y, one does not have a y. So those can't be combined. That's already simplified. 15y, obviously, there's nothing we can do more with that. It's already just one term, so that's already simplified. So it's going to come to this last expression. In this last expression, to simplify this, we can distribute. So we can say this is equivalent to 5 times 2y plus 5 times 1. 5 times 2y is 10y, and then 5 times 1 is 5. We know we have to do multiplication before we add, so you can technically do both of those in the same step. Just be careful with that. Okay, so if you'll notice in the end, we ended up with 10y plus 5, and our first expression also was 10y plus 5. So which of the following expressions are equivalent? We could say 10y plus 5 and 5 times the quantity 2y plus 1 are equivalent because they both simplify. Try again. They both simplify to 10y plus 5. Okay. Another option you could do is you could try substituting numbers in. So you can pause if you're still writing any of this down. I'm going to cover some of this up. So like we talked about earlier, if these are equivalent, we should be able to substitute any number in place of the variable and it'll work. And this is the reason why I mentioned earlier, 1 is not always a good number to try, because if I tried this, this would be 10 plus 5 is 15, 15 times 1 is 15, and you might go along there and think, oh, these are equivalent to each other. So 1 is probably not the best number to choose to substitute. I'm going to try a 2. So if I substitute a 2 in, we've got 10 times 2 is 20, plus 5 would be 25. In our second case, we substitute a 2 in. 15 times 2 is 30. And the last case, we substitute a 2 in. Inside the parentheses, 2 times 2 is 4. 4 plus 1 is 5. And then 5 times 5 is 25. So notice we got the same answer for both of these. So that's another way you can check for equivalent expressions, but it's also going to be in your best interest to learn about simplifying, like I mentioned earlier, about actually taking in this last expression and distributing and getting that to be 10y plus 5, and then saying, okay, it's equal to this other 10y plus 5 then. So this gives you a little bit of an idea of how to generate equivalent expressions, and we'll be talking more about this in another video. Have a good day.